So we're going to use what we've just learned, and that's that dy dx gives us the gradient, to find turning points for particular functions. Now, I like to work in templates, and these templates are like little patterns that if you put over any question, it'll allow you to solve. Now, this template for finding turning points looks a little bit like this. Your first process is to find dy dx, given that you've got the function. Your second one is to find x values when dy dx equals 0. We know turning points happen when dy dx is equal to 0. So once we've found dy dx, then we've got to find what x values will make dy dx equal 0. So that's solving an equation. Third step in the template is to find the corresponding y values for each x value. And how do you do that? Well, you go back into the original equation for the function and substitute the x values in to get the y values. And the fourth step and the last step of this little template is to determine if the turning points, we'll use TP for turning points, are maximums or minimums. A maximum is when the gradient will go positive, 0, negative, and a minimum is when the gradient will go negative, 0, positive. So that's a minimum. All right, let's have a look at the example. So we've got y equals 2/3, this is in your notes, x cubed minus 6x squared plus 16x plus 1. So there is my function. At this stage, we don't have to sketch it. We don't even have to know what it looks like. As a general rule, the number of turning points will be 1 less than the highest power of x. So we've got x cubed here. So I'm expecting that we will get 2 turning points for this, what we call a polynomial. Now that rule doesn't always occur, because if you've got like y equals x to the 4th, that still only has 1 turning point. That's like a very steep y equals x squared like that. It only has 1 turning point. So it's a general rule, but it's just something to keep in mind when you are doing these types of questions, that, all right, we've got an x cube in a polynomial here, so there's a good chance we're going to get more than 1 turning point. We'll possibly get 2. Okay, so let's do our 4 steps. Our first one is to find dy dx. So dy dx, so we'll do step 1, find dy dx. And when we multiply 3 times 2/3, we'll get 2x squared minus 12x plus 16. And so we've done our first step, and that is to find dy dx. The second one is find x values to make dy dx equals 0. So we'll do step 2, dy dx equals 0. But what is dy dx equal to? It's equal to this, 2x squared minus 12x plus 16. Okay, I've got to solve this. I've got an equation. First thing I'll look at is, can I divide right through by something? And yes, I can. Now, you can't divide right through by x. If this was an x cubed, an x squared, and an x, you can't divide right through by x because you'll lose a value. So, but we've got 2 as a factor here, so we can divide by 2, and we get 0 equals, and divide that by 2, divide this by 2, we get x squared minus, divide that by 2, we get 6x plus 8. And we need to be able to solve that. Now, how can you solve that? You've got 2 ways. You should know your quadratic formula, or it's always sometimes simplest to factorise. And we use the cross method. We've got x and x. Now, factors of 8 are 8 ones or 4 twos. Now, 8 ones, we're not going to be able to get a 6 out of 8 and 1, but out of 4 and 2 we can. So we've got a 4, 2. Now, this positive tells us these 2 signs have got to be the same. This tells me when I add the 2, when I multiply along the crosses, I get a negative. So both of them have to be the same, so both of them have to be the negative. So when I multiply that times that, I get minus 4x. When I multiply that along that arm, I get negative 2x. you always add the two together and hopefully you get the middle term, and indeed you do. So we know that these are the factors. So we get x minus 4 and x minus 2. So what values of x are going to make this equal to 0? So you either this must be equal to 0, x minus 4 equals 0. Solve that, take the minus 4 to the other side, so you get x equals 4. Or either that has to be equal to 0, x minus 2 equals 0. Take the minus 2 to the other side, you get x equals 2. So we've got turning points at x equals 2 and x equals 4 because that is where the gradient is equal to 0. So we've done, what have we done up here? We've done that and we've done that. Our next step is to find the y values for each x value by substituting in the original equation. So step 3, when x, and I'll do the smaller one first, x equals 2, you've got to substitute way back in the original equation, which is up here. You get y equals 2/3 2 cubed minus 16 times 2 squared plus, sorry, that should be 6, not 16. One step ahead of myself there. So that's 6 times 2 squared plus 16 times 2 plus 1. And when you work all that out on your calculator, you'll get 14 1/3. And we've also got to find out where what y value for the other. We've got when x equals 2, we've done that. Now we've got to do x equals 4. You get y equals 2/3 4 cubed minus 6 times 4 squared plus 16 times 4 plus 1. And for that we'll get 11 2/3. So my turning points are at 2, 14 1/3 and 4, 11 2/3. So they are my two turning points. So we've done the first 3 steps of the template. The fourth one is to determine the nature, whether they are maximum or minimum. Alright, so how do we do that? Alright, so we've got to see what's going on with the gradient. We know that when x equals 2, we've got a 0 gradient. So we could, if you like, set up a table. So when x equals 2, we could set up a table and we've got, we need 3 columns here. So when x is equal to 2, we know that dy dx, no, let me do that a little bit differently, I think. So we've got our x value, we'll just add another one, and we've got dy dx. So we know when x is equal to 2, dy dx is equal to 0. We want to see what's happening with dy dx on either side of x equals 2. Now how do we know values? We can just choose some random values, but not wildly random, because we've got to be aware that we've got 4 here, another turning point. So if we pick values on either side, we could go x equals 1 and x equals 3. It would be wrong, for instance, to say let's go too far away from 2 and say let's go x equals -1, and so that's 3 less and 3 more 5, because x equals 5 is going to be on the other side of this turning point, and it's going to give us a false impression of what's going on. So it's important to make sure that you just choose values very close to where dy dx equals 0. So 3 is in between 2 and 4. So this will be a good one because we can use 3 as being the one that's just slightly less than the 4. And when we substitute x equals 1 in dy dx, so if we put 1 in dy dx, so we've got dy dx is equal to x squared minus 6x plus 8, and we put x equals 1 in there, we get 1 minus 6 plus 8, so 1 and 8 is 9 minus 6 is equal to 3. And if we put 3 in there, we get 3 squared 9 plus 8 is 17. 17 minus 3 6s 18. So that will be 17 minus 18, negative 1. So all I've done is substituted 1 in dy dx, 3 in dy dx to find out what's going on. From this we can see that we're going from a positive gradient when x equals 2 to a 0 gradient, and then when x equals 3 to a negative gradient. So therefore we have a maximum at x equals 2. Okay, when x equals 4, we draw up another table. X dy dx. Now it's quite convenient here that we've got a point just less than 4 that we've already used on the other side of 2 here. So 3, 4, we know that dy dx is 0 when x is equal to 4. And we'll just, for simplicity, just say let's go to 5 there. And we know when we put 3 in, we've already calculated that dy dx is negative 1. So all we've got to do is substitute 5 in here. And we get 25 plus 8 is 33 minus 6 times 5 is 30. So 33 minus 30 will be just equal to 3. So when x is equal to 4, we've on either side we know we're going from a negative gradient, x equals 4, positive gradient, so this is negative, positive, negative 0, and when x is 5 on the other side we've got positive gradient, and that must be a minimum. So we have a minimum at x equals 4. So we were asked to find the turning points and the nature of the turning points, so therefore we can now quote the answer, and that is that we've got a local maximum at x equals, oh well, let's just give the coordinates of the point xy, so local maximum at x equals 2 and y equals, what do we work it out up here, 14 1/3, and we have a local minimum at 4 11 2/3. Okay, so that's addressed the question. We've given the solution, we've given x and y, not just the x values, but the x and y values of where the turning points occur, but as well we've identified the nature of the turning points, whether they are maximums or minimums.